Right, today's video we're going to have a crash course on logarithmic functions. Right, but basically we're just going to learn how to solve various types of logarithmic equations. Let's look at what are the possible types of questions that you may encounter. Grade 1 questions. You're given the logarithmic equations, right? So you're supposed to find some values of x. I think this is pretty straightforward. This one you just have to change it to the index form. Possible kind of questions would be these, where you just apply the product law, right? In the there are four laws, if you recall. We have the quotient law, product law, power law, and the change of base, right? So questions 2, for this grade 2 questions, basically you just apply the product law. So pretty straightforward. All right, so a more difficult questions would be you still in these questions here, you're all given the same base, common log LG, right? So you still apply the quotient law, but you may need to do some manipulations. That means you need to change 1 to log 10 so that it can apply quotient law again on the right hand side. Oh, sorry, left hand side. So it's slightly harder than the first two questions we mentioned earlier. Right, and then for these questions, yeah, you may need to use substitutions method. So again, it's one level up. Right, this one definitely you have to apply the change of base. Okay, so sometimes questions can be in this form, right, where you're given two logarithmic equations and then you're supposed to find expressed something in terms of P and Q. So this is considered rather a high level question. Right, this is another type of questions that you may encounter. Right, so we'll run through all these solutions for all these questions. For these questions, like what we mentioned earlier, it's rather straightforward. Okay, you just have to apply, just have to change it to the index form. So if you have forgotten how to do that, let's do a recap. Okay, so if you're given a logarithmic equation, right, how do you change it to the index form? Right, first of all, recognize the base. So in this case here, the base is a, right? So you write down the base first, okay? And then the answers will be your power, right? That will be equals to y. Okay, so the important thing is that you have to identify the base. Once you know where's the base, you start off by writing down the base. Okay, and then the answer will be the power, and then the y will become the answer. Okay, so let's try to do the first question. Right. So x is my base. So we start off with the base. Okay, then the answer here will become my power, and that equals to 64. All right, so I want to find the values of x. So what do I do? This is a pretty cool method. You just bring it to the power 1/4 on both sides. Why do you do that? Because 4 times 1/4 will give you 1. Basically, you're finding the values of x, meaning you're finding x to the power 1. So that will give you x to the power 1. And 64 to the power of 1/4, what would that be? You can easily use the calculator. 64 to the power 1/4. 64 to the power 1/4. Okay, so that will give you 2.83. All right, depending on the question, sometimes they may want you to leave it insert. Right, so if you want to leave it insert, then you can't use the calculator. All right, so if you have to leave insert, then how are you going to work out the answer? right? So on the left hand side, we'll still get x to the power 1, which is just x, right? Then 64, 64, it's 2 to the power of 6, and that will gives you 2 to the power of 3 over 2. Okay, and if you write it in radical form, right, remember what we have learned earlier on in the chapters of solving exponential equation, right? The denominator will be outside your radical, and then the numerator will be inside. So in this case here, we're talking about square root, so it's actually not necessary to put that little 2 there. Okay, so that will be my values for x. If you need to leave it in the cert form, otherwise you can just use a calculator to get the answer. Right, so this is pretty straightforward. Okay, let's do this one using the same method as what we have done earlier. We identify the base. So the base here is base 3. So you start with 3, right? Then the answer here will become your power. So basically, you're just finding x equals 3 to the power 4, which is 81. That's the answer. I think before you solve any logarithmic equations, I think it's good that you write down the 4 laws. The first one will be your product laws. Second one will be your quotient law. Third one will, if you have a power, you can just bring the power down. And then of course, we will have this change of base. Okay, so it's always good to write down all this law, and then from there we see which one we can apply. So if you look at what you're given here, okay, you're basically given 2 log, and then the operation in the middle is a plus. So if you were to compare with what you have on the right hand side, then we can see that we can use this one. This one it's similar to what we have here, right? Right, so we can use the product law. Okay, so this is like your letter M. This will be like your letter N. Right, so if you combine them, you will get log base 5 x times x minus 4 equals to 1. Okay, so once you get that, it will be similar to what we have done earlier on in question 1. Right, we just change it to index form. So this is our power. So we start with the power. Oh, sorry, that is our base. So we start with the base. So that's base 5. And then the 1 here become your power. So 5 to the power 1 is equals to x bracket x minus 4. Right, so how do we solve it? We just have to expand your right hand side to get x squared minus 4x, and then bring the 5 together with it to form a quadratic equation. Then the next thing is you just factorize it. Right, and you get x equals to 5 or x equals to negative 1. Now always remember that there are certain conditions for log to be defined. There are certain conditions. Okay, what are the conditions? Okay, so for this to be defined, first of all, the values of b, alright, must be more than 0. It must be a positive values. and your a must be also a positive value but cannot be equals to 1. So these are the conditions that for log b base a to be defined. Right, so if you look at the answers you get for x equals to -1, okay, this value you would have to reject. Why? Because if you were to substitute inside here, you will get log base 5 -1, which does not satisfy the definitions of log b base a. Okay, because your b must be more than 0, must be a positive value. Okay, so this is one way of doing. You just convert it to index form. Now another way of doing it is you just basically, if you want to solve logarithmic equation, you just have to make sure you have log on both sides so that you can just cancel off the log. What do I mean by saying that? Right, so if you were to continue from here, I have log base 5 x bracket x minus 4, right? So all I need to do is introduce another log on my right hand side. So what is 1? 1 is just log 5 base 5. Log 5 base 5 will give you 1. Okay, so then you see that you have log on both sides really. So then it means that x times bracket x minus 4 gives you 5. From there, you can just do the same as what we have done on the left hand side. So that's another way of doing it. So let's look at this question. So like what I've mentioned earlier, okay, we always write down the laws. I think it's good that you write down because then you will remember it, because this will not be given to you in the exam. So right, so you have to remember it. So if you write down, keep writing down, you will remember the laws. All right, okay, so this one here, we can apply the quotient law, can apply this guy here, okay? Because what you have here, it's negative in the middle, and you have two separate logs. So we can apply the quotient law. So your m is basically your x squared minus 4x minus 2, and then your n is x minus 2. Right, so we can apply the quotient law that will give us LG. LG is common log. So you would have x squared minus 4x minus 2 divided by x minus 2 equals to 1 minus log 2. Right, so this here you realize that I need to do something to, okay, remember what we said earlier on? To solve most of the logarithmic equation, you just have to make sure you have log something equals to log something. Log square equals to log circle. So once you achieve that, then your square is equals to the circle because the log can be cancelled off. So we have to think of a way to convert this into one single log. So how do you think we can do that? How do you think we can do that? Yes, we can actually do that by introducing a log. That means what can I replace 1 with? LG is, remember LG is log base 10. Right, so to get 1 means if I have log 10 base 10, I'll get 1, right? So I can actually rewrite my 1 as log 10. Okay, log 10 base 10 is 1. Log 2 base 2 is 1. Log 3 base 3 is 1. So on and so forth. Right, so once I have introduced log 10 there. Can you see here? I can apply the quotient law again. So I've applied the quotient law. So that will give me 10 divided by 2. That gives me 5. Right, very good. So now I have log on both sides. Can just cancel them off. So this guy will be equals to 5. Okay, so how do we continue? Okay, I need to erase all this. There's no space for it. Right. So we need to do some algebraic manipulation here. So you can write 5 as 5 over 1. And then you can just do a shortcut cross multiply. Simplify everything. Negative 5x minus 10, so become plus 10. And then you'll get x squared minus 9x plus 8 equals to 0. You end up getting a quadratic equation where you can factorize it. Okay, so you will get x equals to 8 or x equals to 1. Now, always remember that whatever answer you get right may not be valid. So you must always substitute back into the original equation and see if it satisfies the definitions of a log. So if you're going to substitute x to be 1 into the original equation, right, for log, so if you're going to substitute x equals to 1 into the original equation, okay, I'm going to erase this one now. Okay, if you're going to substitute inside here, right, can you see what you'll get will be log 1 squared minus 4 minus 2. So 1 minus 4 minus 2, you end up getting a negative 5. So you can't have negative 5, right, because that will not satisfy the definitions of a log. So therefore, x equals to 1, you will have to reject the answer. And then how about x equals to 8? So you have to substitute x equals to 8 also. So that will give you 64 minus 32 minus 2. Yes, you get a positive 30. So x equals to 8. And then you have to substitute inside here also. You will have 6. So that's okay. X equals to 8. It's okay. You can accept it. Right. So to summarize for this question, right, what we have done is we apply the quotient law. And what we have done here is that we write 1 as log 10 base 10 so that we can apply quotient law again. And then we'll get a quadratic equations where you can factorize it. And you need to check if the answers are valid by substituting them into your original logarithmic equations to see if it satisfies the definitions of a log. Okay. If you look at this question here, we will have to apply change of base, right? Because on the left hand side is base 5, on the right hand side is base x. So let's write down the formula to apply the change of base. Okay, let's say if you have a log that is base a and you want to change it to base c. How do you do that? Step number 1, you just draw a horizontal line. Step number 2, just write log at the numerator denominator. Okay, and then in step number 3, write down the base that you want to, the new base that you want it to be. In this case, if you want it to be base c, just write down. Make sure that the size of your base has to be smaller than all other letters. Okay, so what's go to the numerator will be b, and then the original base will go down to the denominator. Right, so this is what we're going to do to this guy here. We're going to change it to base 5. So step number 1, okay, write this first. Write down the base 5. Make sure the size is smaller than all other numbers. So what goes on top? 625 go on top. What goes below? The original base, which is base x. Right, so next step. What do? We do a shortcut. We do a cross multiply. So what we have is log x base 5 times another log x base 5. Now you must be very careful with that. So we are having log x base 5 times another log x base 5. So what do we get? We will get log x base 5 to the power of 2. Okay, if you can't really manage that, right, never mind, we can use substitution. So from this step, we can let log x base 5 equals to a. I think using substitution may be easier. So what you get will be a over 1 equals to log 625 over a. So if you do a cross multiply, you have a squared equals to 1 times log 625 base 5 will be just log base 5 625. Right, you have a squared equals to that. Okay, we're going to simplify this one. So how do you simplify that? So 625 is just 5 to the power of 4. You can use your calculator to verify. 5 to the power of 4. Yes, give you 625. So we have a squared equals to log 5, then 5 to the power of 4. So which law can I apply here? Okay, you have a power there. Your power is 4. So once you have a power means you can apply your power law. So what do you do with the 4? You can just bring it to the front. So power law is just bring to the front or bring it up. It's just bring down, bring up. That's all. Okay, so what is log 5 base 5? Basically, this is just 1. So you have a squared equals to 4 times 1 gives you 4. So a will be plus minus 2. Alright, so remember that a is a substituted value for log base 5 x. Right, so we have to put it back to find the actual variable that we're looking for is x, not a. A is just the middleman. Right, so from there we can just convert it to the index form. Okay, start off with the base. So in this case, it's base 5, right? So 5 to the power of 2 equals to x. So therefore, x is equals to 25. That is one answer. Then what is the second answer? Second answer is, I'm going to continue here because we've got a lot of space here, but little space over that side. I will have log base 5x equals to negative 2. Right, do the same as what we've done earlier. Alright, start off with the base, so it's 5, base 5, so 5 to the power of negative 2 equals to x. So x is equals to 1 over 5 squared. That gives you 1 over 25. So this is the second answer. The substitution method is really a very useful method. Okay, in a lot of problem solving. Right, quite obviously, these questions you really have to apply change of base. Right, so let's write down the formula for applying the change of base. Now, what I mentioned earlier, just write down a few times and then you'll remember it. Okay, so here we're going to change it to base 2. You can change base 2 to base 4 or base 4 to base 2, but usually we'll change the bigger number to the smaller number. Okay, so LOG first, LOG. So if you want base 2, write base 2 there. Right, make sure that the base is smaller in size as compared to all other numbers. So the numerator will be 2x plus 13. Denominator will be original base 4. Whatever that's on the left hand side, don't just continue writing it. Okay, so which one can I apply? The numerator or denominator? Yes, the denominator, I can simplify it. I I can simplify the denominator because I can write log 2 4 as log base 2, 2 squared. 2 squared gives you 4. Okay, then I can bring my power down to the front because log 2 base 2 is 1. And then I'll get 2 as the answer. Okay, right, then the next step is you just do a cross multiply. Right, remember what we said earlier? Okay, to solve logarithmic equation, you just make sure you must have log something equals to log something, and then so that the log and the log can be cancelled off, and so your something equals to the something. So, right, so now what is in our way is this guy here, right? So what do we do that? What can we do with it? We can just apply the power law, right? Apply the power law. We can just bring it up. Bring it up will become like this. Okay? Right, then you will have log base 2 on the left, log base 2 on the right. So we can just get rid of it. And then we can just expand this. Simplify it to get a quadratic equation. Factorize it. And you get x equals to 6 or x equals to -2. Right, our story does not end here. You have to check for the validity of the answer. So quite obviously x equals to -2 has to be rejected. Why? Because when you put x equals to -2 here, what will you get? You get log base 2 -3, okay, which does not satisfy the definitions of the log. So therefore x equals to -2 has to be rejected. How about x equals to 6? X equals to 6 is alright because 6 minus 1 is 5. So log 5 base 2 is fine. You have to substitute to both the left and the right side. But the right side is alright because you will get 25, log 25 base 4. So that's fine. Alright, so for these questions to summarize, okay, I think this is the important steps. If you are not too sure, you may want to look at these steps again. Okay? And then of course we apply the change of base. And also we apply the power law. This is a slightly different question from all the logarithmic equations that we have dealt with. Right. So if you look at part 1, so when you look at solving logarithmic equations, basically there are only very few concepts involved. The very important one is if you're given a logarithmic equation, you must know how to change it to index form. Or if you're given an index one, you must know how to change it to logarithmic form. So from here, right, if you're asked to find the values of x in terms of p, right, so how do we begin? Where do we begin? Of course, we begin from what you are given. Okay, you must always start from what you're given. So if you're given log 9, log base 9, x equals to p, okay, remember what we mentioned earlier? We can actually convert this into index form. So let's start off with the base first. So your base is 9. So we start with 9. So 9, the power will be your answer, right? So 9 to the power of p is equals to x. So that's it for part 1, because you're supposed to find x in terms of p. If you want to simplify further, then you can write 9 as 3 to the power of 2. And that will give you 3 to the power of 2p. That would be a more simplified answer than 9 to the power p. Okay, let's look at part 2. Right, so you have 3x, 3 times x. So if it's 3 times x, which law can you use? Yes, the product law, right? The product law. Okay, we can use the product law. So that will give us log base 9. Use the product law will give you log base 9, 3, then plus log base 9, x. Alright, so this one here we know is equals to p, right? But this one is a bit challenging. Okay, so in the chapters of log, right, there are certain very basic concepts that you have to remember. Besides the 4 laws, the product law, quotient law, change of base, power law, besides knowing the definitions of log, like it needs certain conditions, and also knowing that like log base a is 1, log base a1 is 0, the special what do you call that, the special property of a log. You must also be able to express express number interchangeably. What do I mean? What I mean is like, for example, you must be able to write 9 as 3 squared, and you must also be able to write 3 as 9 to the power half. Okay, these are very useful tips. So for example, in this case here, right, you must be able to write 3 as 9 to the power half. Why? Because I want to, if I know that I can write 3 as 9 to the power half, square root 9 give me 3 lah. Then can you see I have a power half there, and then I can apply the power law. So I can just bring down the power law, I'll bring down the half, and then I would have log 9 base 9. And not log 9 base 9 is just 1. So can you see? So that will give me half plus p. Okay, so to be able to solve logarithmic equations well, these are some of the little tricks that you must know. You must have all these tricks inside your bag lah. So when you need them, you can just take it out. Okay? Right, so let's continue. On to part 3. So part 3, quite obvious you have to apply change of base. Right, because you are given base 9, but in the questions, you are asked to find log base 3. So we have to apply change of base. Alright, so base 9, 3. Okay? And then we mentioned earlier on, you must be able to write 3 as 9 to the power half. So you're going to write 3 as 9 to the power half. Then you apply the power law. So the log 9 base 9 is 1. And then you're going to substitute log x base 9 to be p. So you have p over half. So p divided by half means 1 divided by half. P means 1p. So you just take 1 divided by half, that gives you 2. So you get 2p. Or you can just multiply by 2 at the numerator multiplied by 2 at the denominator. So you have 2p over 1, which is just 2p. Okay, so that's part 3. Right. Likewise, for part 4, we have to apply change of base. So we're going to change to base 9. So it's quite easy. Okay, so 81 is 9 squared. Then you apply the power law, bring the 2 down. So that gives you 2 over p. Okay, so to summarize, there are some of these tricks that you must know. Like for example, you must know that you can write 4 as 2 to the power of 2, and then 2 you must know that you can write it as 4 to the power of half, so on and so forth lah. Okay, so they can apply the power law. Come to the last questions, which I considered the most challenging one. Okay, because you're supposed to find log y base a in terms of p and q. Right, you're given 2 equations there. Okay, so if you look at what you're supposed to find, can you see that there is no x term there? Right, so in other words, I think we will have to some kind of solve the 2 equations simultaneously, right, to find the values of y in terms of p and q, then substitute inside. Okay, so how do we solve the 2 equations simultaneously? Right, let's start with what you're given. As usual, we have to start with what you're given. Okay, what do we do? I think we can just change it to index form law. So to change the index form, that's start off with the power. So the base. I keep saying the wrong thing. Start off with the base. So the base is a. So it's a to the power of p equals to x cubed y. So we're going to call this equation 1. Okay, and then also from this, start off with the base. The base is also a. So a to the power of q equals to x over square root y. Wow, kind of confusing, oh. Okay, never mind, don't worry. Right. Let's do a cross multiply, and I'm going to make x the subject here. So x will be equals to a to the power of q times square root y is y to the power half. So I'm going to substitute 2 into 1. And then see what happens. I hope I don't get something that is very messy. So I would have a to the power of q. Oh, okay, I need to open up the bracket for here. So then I will have a to the power of 3q. Then times y to the power of 3 over 2. Then times another y. That will give me a to the power of p. Okay, just follow the arrow. Alright, I can group these together because they're the same base and the operation is a multiplication. So that will give me y to the power of 3 over 2 plus 1. 3 over 2 plus 1 will be 5 over 2. Then times a to the power of 3q. Give me a to the power of p. So y 5 over 2. I need to find the values of y. So that means I have to make y the subject. So I need to bring a to the power of 3q over to the other side. Okay, so that will give me a to the power of p minus 3q. Wow, pretty confusing. Okay, so to make y the subject, what do? I just multiply the power with 2/5, because 5 over 2 times 2/5 will give me 1. Then the other one also I must multiply by 2/5. That's how you balance the equation. Otherwise the equation will not be balanced. So you will have y to the power 1 on the left hand side. Then the right hand side will be a to the power of 2/5 p minus 6/5 q. Okay, so I have managed to find the values of y. Then what do I do with it? Yes, you need to substitute inside here, because this is what you're asked to find in the equations. You're asked to find log y base a. So after finding the values of y, you just substitute inside there. Okay? So I'm going to continue from here. Right, so log base a y will be equals to log base a. Y is a to the power 2/5 p minus 6 over 5 q. Okay, so what can I do with the power? I can apply the power law, right? So I can just bring it down to the front. And I'll end up getting log a base a. And what is log a base a? That will give me 1. So then your answer will be 2/5 p minus 6/5 q. Okay, that will be your answer. So this one I think is rather challenging. So if you don't quite get it, you will have to look through a few times. And please don't give up. Okay, after looking through a few times, I'm sure you'll be able to do it. Right, so we have come to the end of the crash course on logarithmic functions, and I must say that we have persevered through. It's not easy, certainly, right, but we have come to an end. So I think all of us deserve a certificate of accomplishment, right? And you should give yourself a big clap.